So today you're going to finish up the mole ratio lab that you started last week. So let's go back over and just kind of talk about what you did in that lab. In that lab, you took some copper wire. So we have some copper wire, and remember that was the solid. And you added some silver nitrate. Now silver nitrate was a white powder, and when you put it into water, you mixed it up really good and it dissolved. Then what you did is you put the copper wire into the solution of silver nitrate. So this was a solution, and it formed copper nitrate and silver crystals. Silver was a solid, the copper nitrate was AQ. So I have a little picture here that goes kind of through that 15 minutes that you let it sit. So you had your copper wire, you coiled it up, you put it into that solution of silver nitrate, and as time went on, the silver crystals started to form on the copper wire, and the solution started to turn blue. At least that's what yours should have been. Now at the picture on the right, the far right here, you'll notice that that top wire that's right at the level of the solution, that none of the crystals are sticking out. They're all at that solution or below, and they get really spiky. They're just kind of fun to watch. All right, so let's talk about some more. Now, one thing I had warned you to be very, very, very careful about is to make sure that you didn't spill any of the silver nitrate, because it is a light sensitive compound and it tends to stain. Now, this was not me from this year. This was actually several years ago, several years ago. But you can see all the little dark spots on my hands. That's caused by the silver nitrate. Now, I forgot to ask you guys, did any of you get silver nitrate on you? Did you end up with the little black spots? I think I had two. It seems like I can never get through a lab without getting a little bit on me, but I think they're already gone. All right, so here is what your lab looks like. From the last lab, you have the mass of the silver nitrate, that's this top number. It should be somewhere around 1.5. That's how much of the white powder, the white solid, the white crystals that you added to your solution. The other thing that you have is the copper wire that you started with. So in your experiment, some of that copper wire disappears. It actually goes into solution. So what you're going to be doing today is you are going to have, remember we are not doing the empty beaker one. I changed up the lab just a little bit. You're going to have the mass of the leftover copper wire, and you're going to have the mass of just the silver by itself. Silver by itself. So how you're going to find that silver by itself, you're going to take your beaker and you're going to get a weighing boat, put the weighing boat on the scale, zero it out, and then you're going to scrape the silver into that weighing boat. Now the scupulas, in case you need something to help scrape, those will be located in the same cabinet as the goggles in case they're not set out. So just a little something to help you scrape everything out. So again, this is going to be just the silver by itself. We are not going to measure any beakers. Okay, so you've got the silver by itself and you have the mass of the copper wire. Now let's look at the calculations that you're going to do. Okay, so let's look at the calculations that you get to do today. The first thing we're going to do is find the mass and moles of copper used. Now in your data, you actually have two copper measurements. You have the copper wire before the reaction and the copper wire after the reaction. The difference in those two is the copper used. So we're going to take the copper initial minus the copper final. And when you subtract those two, you get how many grams of copper that you used. Now, we do need to take this another step, because not only do you need to find the number of grams, you also need to find the mass. To find the mass of copper, well, you're just going to say 1 mole copper has a mass of, remember we do this by looking at your periodic table and finding out copper is 63.5. At least I sure hope it is. I don't have a periodic table in front of me. This is going to give you moles copper, however many moles of copper you have. The next one we want to look at is the mass and moles of silver produced. Now this is where I do vary from how the lab is written just a little bit. So you only have one silver measurement. The very top measurement is silver nitrate. We don't want silver nitrate, we want silver. Silver should be the last measurement that you took, where you scrape the silver crystals and put them in a weighing dish. So the mass is just that number. You don't have to do any calculations. So you'll have however many grams of silver. Now again, we're going to change this to moles, and you're going to say 1 mole silver is 107.9 grams. Do you remember where the 107.9 came from? Yep, came from the periodic table. And that's going to give us moles of silver. All right, on to the next one. The next thing we want to do is to find the mole ratio. So the purpose of this lab was to experimentally determine what the coefficients should be in that initial reaction that we have. So we want to compare the moles of silver produced to the moles of copper used. So we're going to take moles of silver on top, moles of silver. So this is the number that you just got. And we're going to divide it by the moles of copper. So that number up here on the top, it goes right here. And you're just going to divide the two numbers. Now, usually at this point, I walk around the room and make sure that everyone's data looks pretty good. Ideally, what you should get on this one is a 2-to-1 ratio. Your number should be really, really close to 2. Some years work better than others. I'm hoping we have a good year. Now, what we're going to do is we're going to take that mole ratio that you just found, and we're going to use it in our balanced equation. So remember the balanced equation, we took copper, added silver nitrate, and it produced copper nitrate and silver crystals. Now, I know from yesterday's lecture, you guys could balance this equation. I know that you could do that. But here we're trying to experimentally verify what those numbers should be. Now, if that last problem worked out right, that means this silver at the very end should be a 2 in front, and this copper should be a 1. Now, from that, you can go ahead and balance the other two compounds that we have in this particular reaction. And ideally, again, crossing my fingers, hope it all works out really good for you. Okay, so now comes the fun one. Well, before I get to the really fun one, let's go ahead and write that equation again. We have copper and silver nitrate reacting to form copper nitrate and silver. And hopefully those are the coefficients you got. Fingers crossed. All right, on this one, we're going to figure out whether or not all the silver nitrate reacted that you started with. So if you remember at the very beginning of the lab, you measured out about 1.5 grams of silver nitrate. So however many grams of, and again, this is the silver nitrate. This is not the silver you ended up with. It was that white solid crystal that we used at the very beginning, that light sensitive compound. So again, that's going to be around 1.5. It's the first number on your data table. And what we're going to do is we're going to convert this to grams of silver. So we had, however many grams of silver nitrate. And we're trying to figure out how many grams of silver you end up with. Now this is a stoichiometry problem, just like what we've been working on in class. So this gives you a little more practice. So this is going to be a 3-step process because we're going from grams of one substance to grams of another. The first thing we have to do is to find that good old molar mass. Now we know silver is 107.9. Nitrogen is, let's see here, 14. And I have 3 oxygens. 3 times 16 should give me 48. And I'm going to add those all together. Well, that looks good. 169.9 grams per mole. Now that 169.9 grams is going to go on bottom, and that's equivalent to 1 mole of silver nitrate. So remember, your top and bottom are always equivalent to some way to one another. Now I'm going to go to my balanced equation and I'm going to look at the molar ratio. I know for every 2 moles of silver nitrate, and that 2 just came from right there. There is 2 moles of silver. So remember, those coefficients are only used in this particular step. Now the last step is to convert this back to grams. We're going to say for every 1 mole silver, there is 107.9 grams of silver. And then you can run through that calculation. Now, ideally, you should end up with around 1 gram, depending on how much you started with. So did you end up with as much silver, that whatever you scraped into the weighing dish, as you were supposed to? Or did you not? Well, that's what the next question asks. Or actually, it kind of goes with this question. Did all of it react? So number 1, you have how much you should have gotten. You have to do the math. And then you need to actually say, yes, I made all I was supposed to get. Or 2, no, I didn't end up with quite enough. Now, if your product was wet, it's going to mess everything up. You're going to have like way over what you're supposed to have. But for most people, you did not make as much as you were supposed to. So then the question becomes why, and that's actually your next question. Why did you not make enough? So think about the experimental design. Could time have made a difference? We talked about the wire is curled and you wanted as much as possible underwater or under the solution. What if it wasn't all under the solution? What if we would have knocked off those silver crystals? Would more of them have grown? So think of some different possibilities of what might have happened, and that's going to be your answer to that why question. Now, continuing on, there's 2 more little mathy things for you to do. The next one talks about, well, what is the price of silver? So looking at the price of silver as of the day that I made this particular presentation, silver was $26.78 per troy ounce. Now, troy ounce is one of those old English terms that we still like to use, and a troy ounce is actually 31 grams. That might be good to know on this next problem. Okay, so that's actually your answer for the price of silver. You just look it up. I looked it up on Kitco, and I just wrote down how much it was worth. The last thing to do is to figure out how much your silver is worth, what you actually produced. How much are you going to be like millionaires? Can you retire? Can I retire? Oh, that would be kind of nice. So to do this one, you're going to take the number of grams of silver. Remember, that was your last entry on the data table. This is whenever you scrape the silver into the weighing dish. Okay, now this is $26.78 per troy ounce, but I have grams, I don't have troy ounces, but the lab gave you a little hint, and I actually wrote it down. I said that there are 31 grams in a troy ounce. And then we could say 1 troy ounce is equal to $26.78. And then you can plug that into your calculator. A couple of hints for you. Make sure that you put this in labeled correctly. Make sure you got your dollars and cents written correctly. Remember, that's one of my very few pet peeves that I have. The other thing to do is whenever you're done, just leave your substances just at the front table. So just leave the silver and the copper wire. I actually collect the silver, and one of these days I'm going to be able to make myself melt it all down and make it into a really cool ring. At least that's my hope. We'll see if it ever actually gets done. So that's the Mole Ratio Lab. If you have any questions, feel free to let me know. And if not, I hope it was a success for you.